Okay, so I want to show you now how to determine a function from a graph. And specifically, we're talking about a sinusoidal function, either cosine or sine. And we could use either, considering that you can shift either one a certain direction and just get sine from cosine or cosine from sine just by shifting. Okay, so let's start with the sort of generic form of a function, of a sinusoidal function. I'm going to say A is the amplitude constant. F, I haven't decided whether it's going to be sine or cosine yet. W, or omega, is what I'm going to multiply to stretch or compress it horizontally. Okay, so that will impact the period. This capital F, I'm adding to the x constant, and that will have the impact of shifting it right or left. That's part of the phase shift. And finally, this capital B will use to shift the function vertically. Okay. So one of the first things I'm going to do, so that this feels a little bit more concrete, is choose between sine and cosine. And again, they're equivalent, assuming you correctly shift. But I think it's more convenient with this one because I can see the peak here at -1, and I can see it's right there at 4, -1. To treat this as a cosine, one that crosses the x-axis at 1 in the base function. If I wanted to do it as a sine, I would have to sort of guesstimate where this increasing 0 is. And it looks like it's probably -2.5. I could do it. It would probably be correct. But the easier way for me is to work with cosine. So I'm going to do cosine. So let's set that up right now. So I'm going to change f into cosine. So already we're partway there. Another thing that I can see right out the gate is that b is 0. We have not shifted this. It extends from -4 to +4 for the y values, which is exactly like taking -1 to 1, the base function, and multiplying it by 4. So that tells me the amplitude, and it also tells me that the midline is still 0. So that b is just 0. And as I said, the amplitude is the absolute value of the difference from high to low. And I can see that, or absolute value of half the difference from high to low, and I can see that it's just 4. So that's going to be 4. I could also treat it as -4, and I'd still be correct. There are several other ways to express this. All right. So now we've got our function, we've got our amplitude, and we've got our vertical shift. What we need now is our horizontal shift and our horizontal expansion and compression. And, I suppose maybe we'll do the shift first. No, I want to do the period first because it's actually really kind of is more interesting. I can see that we're told that we have the points -4 and -4, and the other point being 2, -4. So the curve is a sinusoidal function. It goes through the points -4, -4, and 2, -4. So that tells me that the period is from -4 to 2. The period is 6. I'm going to find a sinusoidal function that matches it, and so the period is 6. So I'm going to solve for the w constant. So t, the period, is equal to the base function period, which is 2 pi rather, over omega. Well, w I'm expressing it as. And I also know that t equals 6 because I just counted it. I can see on the graph, -4 to 2, that's 6. Okay. So that means that 6 equals 2 pi over omega. What I want to do now is just solve for omega, which I'm writing as w, so I'll just call it w. Okay, so I multiply both sides by the w. Then I'm going to divide both sides by 6. Okay, almost done. And so that is pi over 3. W is pi over 3. All right, only one more term we need to solve for, and that's the phase shift, or I'm just going to call it the horizontal shift, which I'm going to call f, capital F. All right. One easy way to think of this is to, as you recall, if you're doing the transformations on a function, you would do the x transformations first, then the y. And within the x transformations, you would do from the outside in. So you would do first the shift and then the expansion or compression. So what I'm going to do is I'm going to factor out that pi over 3. So what we're doing in essence is, at the end, we would do the f transformation first, the horizontal shift. So I'm going to shift this a certain number of pi over 3s. Okay? And I can see that this, instead of being at 0, at x equals 0, it's at x equals -1 is the local maximum. So it is shifted 1 unit, if you will, to the left. Now, left means that it's going to be addition. And 1 unit means it's 1. Okay, so this is actually what we would do. If we had this base function, first we would do the shift, 1 unit left. Then we apply the expansion, and that's pi over 3. So if I wanted to write this just in the form I've written, where I have not factored out the pi over 3, I'd write it like this. Pi over 3 plus pi over 3. And then I don't need that second paren. So this is one way to write the function. And if I enter this into the assignment, it'll mark it as correct. So preview it. Hey, syntax is okay. Submit, and it's all green. Submit. Oh boy. Sorry about that. I had a little internet glitch there for a second. Anyway, submit it, and yes, it says that the answer is correct. That is one way to express this function. There are other ways. So one way that if you show the answer, you'll see it's expressed as -4 cosine pi over 3 times x minus 2. The reason for that is that if I multiply if I flip this, multiply it times -1, that would change where the peak is, where the local maximum, and it changes the extent by which I need to shift it. It would need to shift 2 instead of 1, pi over 3. Other ways that we could see similarities between these. So here's the function as I've expressed it. So I set it as 4 cosine pi over 3 plus pi over 3, and that's this. But if I wanted to express it the other way, if I wanted to make sure I shifted it with a negative constant, I could see that instead of shifting it 1 unit to the left, if I want to always shift it to the right, as we do when we speak of phase shift, the next peak is at 5. So that would be minus 5 pi over 3. And that's correct also. I could express this as I showed with a negative product on the y. I could also express this as a sine. So remember the relationship between sine and cosine. Here's a cosine, base function. And here's a sine. Oops, this sine. Here's the sine. And what you can see is that if I wanted to turn cosine into sine, all I have to do is shift it up a quarter. Pi over 2, a quarter circle. So I can do that by adding to the sine plus pi over 2, and that would do it. So I could do this as sine and then add pi over 2. They're all equivalent, and that's sort of one of the important points about trigonometric functions, is there's an infinite number of ways to express the same equation.